Hey everyone, welcome back to another Python video. In this video, we're going to be creating a function that can return a list of all prime numbers under n. So we're going to create a function that takes n as an argument where n is a positive integer. The program will store and return the list and store all the prime numbers that are less than the n value that we've been given. All right, so what I've done is I've imported or copied over some of the functions that we created before. This function right here creates a list of factors for this value, and this checks if this given argument is indeed a prime by using this function right here. By checking if a number is prime, we get to determine which numbers are prime, and then we can add it into this empty list right now. So we have these two functions ready to go. So we will be coding this function. It's going to take a single argument of upper limit, and we're going to just use a for loop, look at all the numbers from 2 to the upper limit, not including it. And if we see a prime, we're going to append it onto this empty list. So here we go. We're going to say for num in range from 2 to upper limit. If you really wanted it to, actually, you can just say that's 2. Then we can do something like this. Then we can go if upper limit is equal to 2. Then we can say return primes. Otherwise, we're going to assume that it's going to be greater than 1. So we're going to be right here. Okay, here we go. We're going to say if the number that we're looking at, we're going to write is prime. If that is true, as in if the number that we're looking at is prime, then we're going to say, well, primes, we can append that number. And after this for loop is done, we should be able to return the number of primes that we have. Okay, so let's check this problem. We need to first test it, print list of all primes under 10. We can write that as prime list of 10 Python bit 41. Okay, and we get 2, 3, 5, 7. 8's not a prime, 9's not a prime, 10's not a prime, and we are not going to go include 10. There we go. Okay, that's functioning properly. Let's try see primes under 100, and that should be 100 right there. And we get all these numbers because they only had 2 factors. Beautiful. All right, we just wrote a very simple function. The first if statement was saying that if it's 2, we can return this. Otherwise, we're going to be for 3 and onwards. It should 3 should only have a list of just having 2 as the only prime under 2 or prime under 3. Sorry, and then we can generate all the prime numbers by checking if that number that we're analyzing from 3 to upper limit is prime, and then if so, we can add that number to our list of primes and return that afterwards. Our range, we're just going up by 2s because 2 is the only even number that is a prime number. So we're just assuming that from 3 to upper limit, if we just analyze all the odd numbers by adding 2 from 3, so we're looking at 3, 5, 7, 9, 11, 13, 15, 17, so on. If we only look at odd numbers, we should be able to just grab and check those numbers instead of checking the even numbers, because we are confident that every even number after 2 is a composite number. Okay, so that was our solution. We were using these 2 functions that we use, and if you have, functions that you like, and you're more than welcome to reuse the functions that you've created in the past to write a code for a new solution or a problem that you face. Okay, thank you for watching. Stay classy.